runs the find device function. You give it the vendor ID and the device ID. And typically you only have one USB Canon installed, so it will find that exact one, and after you run the open command, you can send and receive messages from the device. Okay. Now this wasn't the whole story. We saw earlier in Perl messages that the kernel already mapped a device driver, which you can't use, to the device, and we call detach kernel driver NP, not sure what NP is, no problem. And it just take the driver away so that we can talk to the device directly. Also, USB is a very versatile protocol, and a USB device has interfaces and has configurations. And simple devices only have one configuration, one interface. So you just select the first one. Now, there's 4 different kinds of transfers from and to a USB device. It's control transfers, baud transfers, which are for retrieving large amounts of data, interrupt transfers for small amounts of time-sensitive data, and isochronous transfers for real-time data, which is for video streaming. And now you need to figure out what is the Windows CD using, what kind of transfer mode is it using in order to talk to the device. So you plug in a program called USB, and there's also been some re-engineering of the DLL that comes with the CD. They basically figured out, you can read it out on the internet, and it's in a reference list that I append at the end. It is control transfers in order to turn the tower left and right, to raise it up and down, and to fire. And there's a baud transfer involved, reading the status. You want to know if the cannon can fire at this point, or if it's all the way on the left-hand side, so you can't turn left anymore. That's the kind of thing you want to get from the cannon, and that's a baud transfer. Pretty arbitrary, but you need to know which one it is so you can simulate it later on. So control transfers and baud transfers is what they found out. The control codes are 1 for down, 2 for up, 4 for left, and so forth. So you can see this maps nicely to a big map. And this is all has been found out by people who basically plug in the CD, ran the USB sniffer, hit the button, and drove the cannon, and then looked at the sniffer and found out, okay, this was code 1 that was just sent. And we can do the same thing from Perl, basically. We just saw that 2 is the code for moving up, and you need to put in a couple of numbers here for the request type and set configuration and endpoint. So we're at a very low level here. Also, there's a timeout of 1 second, and we need to convert. We need to convert the number hex to a single byte using the character function. And if we send that down to the cannon will start moving, but it won't stop. And in order to have it stop, you need to send another command, which is the stop command. In order to figure out if we're all the way to the end already, we send a control message down with the hex number 40, and we read back the data that comes back from the device. And this is kind of awkward because the device will, most of the time, will send back a 0, which means I can't do anything. I can do just about anything. But if you're all the way to the left, it will send back the code for going left in order to indicate that it can't do that. If you get a 0 back, this means you can move the cannon in either direction and you can fire it. And if you get back, for example, 8, I forgot what 8 was, fire or something, it just says that it's currently reloading, the motor is reloading that spring that fires up the rocket. So in order to demo that real quick, let's see. There's another copy of this. So this is the code to move the cannon up, wait 150 milliseconds, which is 1/8 of a second. It's really short, and then stop, and then read out the status. And you need to look very closely at the cannon now. If they run that script, it does nothing. Okay, you move down, put in the wrong code there. And let's say I'm letting it move up now, and I'm waiting for user input. So it's going to move up until I hit that return to. Get dangerous here. Now, as we talk about anything, there's a module on CPAN that provides a nice abstraction to this pipe filling that you don't want to deal with. And it's in the correct interface, device UV missile launcher, rocket baby. And it provides two different functions. One says can do, and the other one is do. And you don't need to remember the bits that 1 is up and 2 is down. You just say stop or left or right, and I've defined a function that does something until it can't do it anymore. So it swivels to the right until it's on the right side. It fires until it's done. And this is going to be the demo. So the script looks like this. Use the rocket baby module, then it goes all the way to the left, all the way down, which means it's going to be ending up right here. Then it will start a timer, go all the way to the right, all the way up, and measure the time it takes to get up and to go all the way to the right. Then divide that time by half. It's going to be located just about here. Then it's going to swivel down about 1/4. And then it's going to fire rockets 1, 2, 3. So if they're not dangerous, don't be alone. Go down. Now it's moving over there. And it has started the timer. And what's going on here is that a couple of times per second, it will ask, am I already at the right hand side? And it will continue if not. Now it's going to go to the middle, lower. Now attention. There's a bug in the program. Okay, thank you for listening.